Hello, welcome to this session on inequalities and equations involving the modulus function. We're going to look here at a reasonably nice example. So when I take the modulus here, the modulus of 4x minus 2, put it equal to 3 minus x, I'm just taking the positive value of whatever 4x minus 2 has. Now this could be two possibilities. The first one is, well, let's just take 4x minus 2 itself and let that equal 3 minus 6. We solve that, we get 5x equals 5 and x equals 1. Now the alternative situation is that we have the opposite sign, that there is a negative version of this, shall we say, negative version of the algebraic expression equals negative 3 plus x. Notice I've taken the negative of the function there. So the easiest way, I believe, is just to do the positive of the function. Take the positive version, the normal version equals the positive of that. And then we take the function equals the negative of that. You could do it the other way. You could say, okay, yeah, negative 4x plus 2 equals 3 minus x. That's just the same, but I just tend to do it this way. Okay, so let's finish off solving this. 3x equals negative 1. X is indeed negative a third. Now that looks fairly straightforward. It's just a case of remembering the strategy. Okay, I've just pulled up a graph of this to try and make it a bit clearer. In blue, you've got the modulus of 4x minus 2, or y equals, to form the graph. In red, you've got y equals 3 minus x. Notice we've got two solutions. There we go. Here we get x equals 1, which corresponds to this, where I've just taken the positive of both. And here, this bit here, gives me negative a third, which you can see there. X is negative a third. And you can see this is what you might call the bounce up of the function, because if y were 4x minus 2, it would just go and continue down there like you can see on the arrow. There we go. But instead of doing that, we have a bounce up because it can't go below the x-axis. And there you go. We're going to have a look now at the inequality. Okay, well, we've solved an equation fairly similar to this. And that's going to be very useful for us because we've got our critical values. Let's have a look at our critical values. Critical values are, there you are, x equals 1, and x equals negative a third. Now we're looking for when the modulus function of 4x minus 2, this graph, is greater than 3 minus x. Now solving an inequality is often done by finding these critical values where the graphs of the functions intersect, looking at the graph and seeing when one is above the other. So when is the modulus of 4x minus 2 greater than 3 minus x? Well, it's here. It's here when x is greater than 1, and here when x is less than negative a third. So our solution to this, having solved the equation, mind, would be x is greater than 1 and x is less than negative a third. Okay, so just to summarise, we've solved the equation of 4x minus 2, the modulus of 4x minus 2 equals 3 minus x. We now have an inequality, and we look at the graph and we just use logic to find the values when the left hand side is bigger than the right hand side. I hope that makes sense.